two more problems regarding concavity and inflection point. So we are going to solve these two problems using these 4 steps. I am not going to read the steps off. If you want, you can take a screenshot of this so you can keep a record for yourself. So number 1 actually is problem number 3. I have f of x equals to x times the square root of x plus 3. So for concavity, we need second derivative. So let's find f prime of x. I gave you the derivative in there in case your derivative is incorrect, because everything depends on derivative. If your derivative is wrong, the entire problem is wrong. I gave you the hint is because I want everyone to have the correct first derivative. So f prime of x. So speaking of f prime of x, I want to do one more thing before I get into that. Why do I need to do this? Here, look, we have a square root. In the previous two problems, you can check out the previous video. They are polynomials. So there is no discontinuity. And we don't need to worry about the domain at all. This one we have a square root function. For square root function, we do have to worry about the domain because square root of negative is undefined. So therefore, we have to make the x plus 3 greater than or equals to 0. So x must be greater than or equals to negative 3. So let's do the first derivative. So using a product rule, that is fg prime plus gf prime. So we have x, and then we bring the 1/2 down, x plus 3 to a negative 1/2, and then the derivative of x plus 3 is 1, and then plus gf square root of x plus 3, the derivative of x is equals to 1, and then I want to simplify as much as I can. So this, we have x, and then 2 square root of x plus 3, and then we plus the square root of x plus 3. I want to make this into one fraction. So therefore, I need a common denominator, 2 times square root of x plus 3. So this is a x, and then the other piece. So this piece right here. So this piece, we have to multiply the top and bottom by 2 times square root of 3. So square root of x plus 3. So therefore, this will be 2 times x plus 3. Where is the square root? You have a square root times a square root, so the square root got cancelled, and then I want you to simplify the top for me. So overall, f prime of x, that is equals to 3x plus 6, which is the same thing as you factor out the 3 times x plus 2 divided by 2 times the square root of x plus 3. So the first derivative is ready, and then you go ahead, take the second derivative using a quotient rule, so which is gf prime minus fg prime divided by g square. So f double prime of x, I am supposed to have a long fraction this time, so prepare a fraction bar, and then 2 square root of x plus 3, and then we square that, and then gf prime, we copy the g, and then f, the f, we can just, what is the derivative for the top? 3x. The top, you can do 3 times x plus 2 or 3x plus 6. So the derivative of the top is just a 3, right? And then a minus f, which is this one, the f prime of x, you can prepare one more for yourself. The top, you either factor out the 3 or you don't factor out the 3. Divided by 2 times the square root of x plus 3. So fg prime, so that will be a 3x plus 6, and then the derivative of the bottom, so that is 2, and then you bring the 1/2 down, x plus 3 to a negative 1/2, and then the derivative of x plus 3 is 1. And then you have to simplify the top all the way to the end. I know it's a lot of work, you have to do it. So you have double prime of x, and then we prepare a long fraction bar, the bottom, so that will be a 4 times x plus 3, and then this is a 6 times the square root of x plus 3. That looks clean, and then these two got cancelled. The 1, we can ignore the 1, and then we have a minus 3x plus 6 on top, and then the denominator is the square root of x plus 3. And then you need a common denominator on top. So f double prime of x. We have a long fraction bar. And then the bottom is 4 times x plus 3. And then this, we need to have a square root of x plus 3. So the square root of x plus 3, once you multiply this by the square root of x plus 3, what do you get? You have a 6 times x plus 3, right? Look, square root of a times square root of a is just equals to a, all right? And then minus, you have a 3x plus 6 minus 3x plus 6, but I want you to remind you that you are subtracting the whole thing. That means you have to distribute the minus to the 3x and the 6. Then you have a minus 3x and then a minus 6. And then you bring the square root to the denominator. So f double prime of x, that is equals to, you bring the square root to the denominator. And then you have a 4 times x plus 3. The top you have a 6x minus 3x, so you have a 3x, and then you have a 18 minus 6, you have a 12. So that is the factor form, that is the simplest form of the second derivative. So once you get into that, you set this equals to 0, and then you solve for x. All right, so when you have a numerator divided by a denominator equals to 0, what the numerator should be? You have a numerator divided by a denominator equals to 0. One thing that I know is a has to be 0 and b can never be equals to 0, right? So we have a 3x plus 12 equals to 0, and then x is equals to negative 4. And then what else we have to pay attention to? In the denominator, we have to emphasize that x plus 3 can never be equal to 0 because I do not want to have a 0 in the denominator. So x is not equals to negative 3. And then do I need to common anything? I have this. And then I have this. What should I say? Now, every time you have a square root function, you have to go back to the domain. What is the domain? The domain is right here. The domain is x must be greater than or equals to negative 3. So here is the domain. The domain is x has to be greater than or equals to negative 3. Is negative 4 greater than or equal to negative 3? The answer is no. So that means this is not in the domain. What does that mean? That means x equals to negative 4 is not a critical number. All right, we just take care of the negative 4. What about x cannot be equals to negative 3? That means the double prime, f double prime, is not continuous at x equals to negative 3. So that means x equals to 3 is the only critical number. X equals to negative 3 satisfy this, right? 3 is equals to negative 3. So that means x equals to negative 3 is a critical number. All right, and then what do we have to test? In the whole problem, one thing that we have to emphasize is x must be greater than or equal to negative 3, right? So that means when x is less than negative 3, we do not consider this piece at all. So there is only one interval to test, that is from negative 3 all the way to positive infinity. And then you don't even need a table. This is simple. You can pick your test value. I am going to pick x equals to 0 to make my life simple. And then I test my 0, f double prime of 0. So f double prime of 0, where is my double prime? My double prime is right here. This is my double prime. So my double prime is 3x plus 12. So we have 3 times 0 plus 12 divided by 4 times x plus 3 and then times x plus 3. So this thing is a positive, so that means the function is concave up in this interval. So concave up on negative 3 to positive infinity. And then what about inflection point? There is no inflection point because when x is less than negative 3, we don't care about this at all. So we are not able to have a concave up and then down or down and then up. So this problem has no inflection point. And one more, the function f of x is equals to x times x plus 3 is always concave up. So that's how you answer this question. All right, let's move on to number 4. So number 4, we have a rational function and we have a square root in the denominator. Okay, let's take a look at number 4. So number 4, we have f of x equals to 6 minus x divided by the square root of x. First thing first, we have to consider the domain. All right, so we have to consider the domain because we have a rational function and we have a square root. So what do we say for the domain? Domain, we have to say that the x right here, so this x must be greater than 0. Where is the equal? You cannot equal to 0 because once you have that equals to 0, then the denominator is 0. So that's why the domain is x greater than 0. When you consider the test interval, I only want the interval where x is greater than 0. And then you find the first derivative, f prime of x. So this one is a quotient rule, right? Quotient rule is gf prime minus fg prime divided by g squared. All right, we square the denominator, and then square root of x, the derivative of 6 minus x is -1, and then minus f 6 minus x, the derivative of the square root is 1/2 x to -1/2. And then you have to simplify this all the way to the end. And then f prime of x, that is equals to negative square root of x, and then minus 6 times 1/2, so that will be minus 3 divided by square root of x, and then plus you have x and x, so you have x and then 2 root x, right? And then divided by the denominator is just an x. So in the numerator, I have to get a common denominator. The common denominator is going to be 2 times root x. The denominator is x. All right, so for each numerator, you have to multiply that by 2 root x. So root x times root x is just x. So first one, we have a negative 2x. And then the 3 over root x, I don't need to multiply the top by root x. I only need to multiply the top by 2. So that will be a minus 6. And then the last one is already in common denominator. So that will be just a plus x. And then I have to put the 2 root x to the denominator. So f prime of x, that is equals to 2 root x times the denominator. The top is negative 2 my plus 1. So that will be negative x. Minus 6, and then root x times x, that is 1 plus a half, right? So that will be 2 times x to the 3/2, and then this is a negative x minus 6. So the first derivative is done, and then we move on to the second derivative, f double prime of x. We square the denominator, so 2x to a 3/2, we square that. And then this is a gf prime minus fg prime divided by g squared. So you write 2x to 3/2, and then f prime, the derivative of the top is -1. And then using the quotient rule, we have a minus, and then f, and then g prime. So the derivative of the bottom, you bring the 3/2 down, so you have a 3x, and then 3/2 minus 1 is 1/2, and then you have to clean up the top. Double prime. This is a double prime. We have a negative 2x to the 3/2, and then plus 3x, 1 plus a half, that is a 3/2. I am doing distribution, and then plus 18 x to a 1/2, and then the denominator 2 squared is equals to 4, and then this x to a 3/2 raised to the 2, you multiply the two exponents, right? So you have 4x to the third, and then clean up the top again, f double prime of x, what do you have? The top, you have a negative 2 plus 3, then you have a 1, right? So you have 1x to the 3 half, and then plus 18x to 1 half. So that is the simplest form. So now you are ready to set that equals to 0 to look for your critical value. So when you have a top divided by a bottom equals to 0, first, the top has to be equals to 0. Plus 18x to a 1 half, that must be equals to 0. You have to solve for this. Let's do that. I will factor the 1 half out, and then this will be x, and then plus 18 equals to 0. So overall, you have the square root of x equals to 0. You have x plus 18 equals to 0. So what do you have? The square root is x equals to 0. The second one is x equals to negative 18. Okay, what is your domain? Let's look it up. The domain is x must be greater than 0. So let me change color to write the domain. So the domain of the f of x is x must be greater than 0. So that means when I consider the test intervals, I want the intervals to be x greater than 0. So you have a negative 18, right? So negative 18 is not in the domain, so that is not a critical number. So that is not in the domain. Not in the domain. So that is not a critical number. So that is not a critical number. And then what else? And then what about x greater than 0? X equals to 0. Is x equals to 0 in the domain? No. So that is not in the domain either. So not in the domain. So x equals to 0 is not a critical number. All right, what do we do now? I found the first derivative, and then I found the second derivative. Okay, I found two critical value. We put a critical point, we put a quotation mark on it. However, none of them satisfy the domain. Then what do? That's why I picked this problem. I found something, but they do not satisfy the domain. That means I will just draw a test interval based on the domain. So I'm going to use x greater than 0 as my only test interval. So we have this, and then we have a 0. Do I consider the value where x is less than 0? No, so I do not consider this place because I want x to be greater than 0. So the only test interval is from 0 to positive infinity. And then you pick an easy test value, x equals to 1, or you can pick 1,000. That will just make the f double prime very complicated. So I have the f double prime on top. So f double prime when x is equals to 1, you have 1 to the 3 half plus 18 times 1 to a 1 half, and then divided by 4 times 1. So overall, that is a positive 18 plus 1 divided by 4. I don't care what that equals to. So that is positive. So that means the function is concave up in this interval. And then there is no inflection point. So overall, the function is always concave up in its domain. Okay, so that will be the end of this problem. I will see you all in the next video. Before I sign out, if you think my lesson is helpful to your learning, please subscribe, give me a like, share this video out to your friends. I appreciate your help really, really much.